Deep inside Uranus and Neptune, something very strange is happening to matter. Under extreme pressures and temperatures, the normal rules of physics being to break down. Scientists now believe there may be a new, unusual states of matter hidden inside those planets. Something that does not fit into usual category of solid, liquid or gas. Because we cannot physically travel into those planets or drill into them, researchers rely on advanced computer simulations. They use supercomputers that combine with quantum physics with machine learning to recreate what matter would do under those extreme conditions. Those simulations allow scientists to model atoms' interaction at pressures millions of times higher than anything we can create on Earth. Inside Uranus and Neptune, conditions are extreme, beyond imagination. The pressure is so intense that ordinary materials are crushed into entirely different forms. Temperatures reach thousands of degrees, and molecules that are stable on Earth, like methane and hydrogen compounds, being to break apart. When this happens, the atoms inside of them are forced to rearrange into completely new structures. One of the most interesting materials studied is made from carbon and hydrogen. Under those extreme conditions, carbon atoms do something surprising. Instead of floating freely or melting, they form a solid, stable, crystal-like structure. This structure acts like a rigid framework, almost like a three-dimensional skeleton. Hydrogen behaves in a very different way. Instead of staying locked in place, hydrogen atoms became highly mobile, but they do not move randomly like a gas. Instead, they move through the carbon structure in a very organized way. They travel through a narrow channel-like pathways instead of a solid carbon lattice. This creates a unique combination where part of the material is solid, while another part is flowing through it at the same time. Because of this behavior, scientists describe the material as a quasi-one-dimensional superionic state. Superionic means that some particles move freely like a liquid, while others remain flex like a solid. The one-dimensional part means that the movement of a hydrogen is restricted to specific direction rather than being able to move in all directions equally. This unusual behavior happens because extreme pressure changes how atoms interact. Under such pressure, the electrons surrounding atoms are squeezed and rearranged. Chemical bonds weaken or shift, and hydrogen atoms are no longer tightly bound to the place. Instead, they can move or hop between positions in the structure. However, the structure of the carbon lattice creates preferred path, so hydrogen motion became directional instead of random. This combination of a solid framework and directional hydrogen flow creates a completely new type of a material behavior that has never been observed under normal Earth conditions. This discovery is important because it may help explain several mysteries about Uranus and Neptune. One of those is how heat moves through their interiors. If a hydrogen is able to flow through channels, it could transport heat in an unusual way, affecting how those planets cool over time. Another mystery is the strange magnetic field of Uranus and Neptune. Unlike Earth's relatively simple magnetic fields, those planets have a complex, tiled and uneven magnetic structures. The unusual movement of the charged particles inside those exotic materials may play a role in shaping of those fields. More broadly, this discovery adds to the idea that the interior of ice giant planets are far more complex than previously thought. We already know that water under extreme pressure can become a superionic form where oxygen atoms stay fixed while hydrogen flows through them. Now, similar strange behavior may also exist in a carbon and a hydrogen compounds. In the end, Uranus and Neptune may not be a simple frozen worlds at all. Instead, they might contain layers of exotic materials and unfamiliar states of matter that only appear under extreme planetary conditions. Those planets could be natural laboratory for physics that we cannot reproduce on Earth, and we only beginning to understand what is happening deep inside them. If you like this video, give it a thumb up and share it. Don't forget to check out Simon Tips, your go-to spot for everything you wanna know.